So in this problem, we have a scatter plot, and the scatter plot shows all these little X's are data points, and they show the time spent texting in hours versus the time spent exercising in hours. So for example, right here, this X right here represents someone who spent 4 hours texting, and that person spent 7.5 hours exercising for this given length of time. And what it looks like happens is the more time that students spend texting, that is, as these little X's move further over to the right, the time spent exercising goes down. And so we have what's called a line of best fit, a line that best approximates all that data, that starts up here at about 0 hours texting and about 9 hours working, exercising. And it goes down to about 10 hours texting and a little over 1 hour exercising. So that is the setup for this problem. So for these 24 students, as the time spent texting increases, the time spent exercising tends to, well, that's what we just talked about. As the time spent texting goes up, the time spent exercising goes down because these dots are all, as these dots get further to the right, they also go further down. So the answer to that one would be they decrease. So for these 24 students, there is positive, negative, or no correlation between the time spent texting and time spent exercising. Well, this line of best fit we have right here has a negative slope. That is, it goes down as we go to the right. And so therefore, there is a negative correlation. So using the line of best fit, we would predict, looking at this problem, using a line of best fit, we predict that a student texting for 6 hours would exercise approximately how many hours? Well, let's see. If we look at the graph right here and take someone who spends about 6 hours texting, here's where that intersects the line of best fit, then move that over. So that is about, I'd say about 4.25 hours spent exercising. So someone who spends 6 hours texting would spend about 4.25 hours working out.